Today's show is one that has made me reflect on just what it takes to understand our universe. More than 2,000 years ago, Plato advocated for teaching our leaders astronomy and said, quote, "Astronomy compels the soul to look upwards and leads us from this world to another," end quote. Basic astro classes teach the discoveries of Eratosthenes in 200 before the Common Era that led to a pretty accurate measure of Earth's radius. Astronomy is an old field of research, and yet our discoveries only advance as our technology to travel, to look up, and to model our results all improve. Yes, I said to travel. Astronomers have been traveling the globe to catch eclipses and other astronomical events since at least a couple hundred years ago. Today, we have stories on researchers looking with the newest instruments at Mars and Enceladus as they work to understand what Earth-tested science may apply on these very different worlds. We look at oscillating baby stars and try to understand how they will grow up to shine. And we share Eric and SpaceX's frustration with weather in Florida and how it likes to keep good rockets down. All of this and more is coming at you today on the Daily Space. I'm your host, Dr. Pamela Gay, and we are here to put science in your brain. If it feels like we're getting a lot of JWST does something for the first time stories this year, it's because we are. This week, the newest images are of Mars. Once again, they have tracked JWST to look inside our solar system, just as they did with Jupiter last month. And what they managed to capture was a portion of Mars' eastern hemisphere in two different infrared wavelengths. These two images have been released along with a reference map collected by NASA and the Mars Orbiter Laser Altimeter. The smaller, more orange image is dominated by reflected sunlight collected at 2.1 microns and matches up to the visible light version. The longer wavelength version, collected at 4.3 microns, is a product of the planet's thermal emission or heat. That image shows which regions of the red planet were receiving the most sunlight at the time of the observation. You can see images in our show notes at dailyspace.org. In addition to the infrared images, JWST also collected a near-infrared spectrum of Mars. While that spectrum is still being analyzed, the initial release shows the presence of carbon dioxide, carbon monoxide, and water vapor. Further data is expected to be collected in the future that will allow for a detailed analysis of Mars' atmosphere, including regional differences and trace molecules like methane and hydrogen chloride. We here at the Daily Space are particularly interested to see these global views on methane. These images and the spectra have not been put through peer review process yet, but will bring updates once the relevant papers make it to press. Well, JWST seems primed to help understand Mars' current atmospheric conditions. A new paper published in Nature Astronomy with lead author Joseph R. Michalski contends that we are vastly underestimating just how many lakes there were back in Mars' more watery period. Estimating the number of lakes on Mars is important to understanding how the planet changed over millennia on both large and small scales. Michalski explains, quote, "We know of approximately 500 ancient lakes deposited on Mars, but nearly all the lakes we know about are larger than 100 kilometers squared. But on Earth, 70% of the lakes are smaller than this size, occurring in cold environments where glaciers have retreated. These small-sized lakes are difficult to identify on Mars by satellite remote sensing, but many small lakes probably did exist. it is likely that at least 70% of Martian lakes have yet to be discovered. End quote. Additionally, all these lakes likely only lasted a geologically brief time, about 10,000 to 100,000 years. And this new paper dates those lakes back to 3.5 to 4 million years ago, which gives a pretty narrow window for the development of life. On top of that issue, Mikalski notes, quote, because of the lower gravity on Mars and the pervasive fine-grained soil, lakes on Mars would have been very murky and might not have allowed light to penetrate very deeply, which could present a challenge to photosynthetic life if it existed. End quote. None of this means we should give up the hope of finding that evidence. We've managed to find life in the wildest of environments here on Earth, including deep underground and in sulfur ponds. Mars isn't outside the realm of possibility, but we're going to have to keep searching, and we may need to search for those smaller lakes too. Follow the water is the theme of much of our quest to find life beyond Earth. From narrowing down the so-called Goldilocks zone to where water can be liquid to the discovery of subsurface ocean worlds, we have pinned our hopes on finding what we recognize as life. Now, scientists led by Jiha Hao have published new models for the composition of the subsurface ocean on Saturn's moon Enceladus and have determined that a key ingredient, phosphorus, should be readily available. Phosphorus is important for the creation of DNA and RNA, the formation of cell membranes, and even bones and teeth in all manner of animal. Up until recently, much of the data analyzed by the Cassini mission couldn't prove that phosphorus was contained within that subsurface ocean. So this team of researchers worked up some new thermodynamic models that simulated the water's geochemistry using that Cassini data. It turned out that phosphate minerals would be, quote, unusually soluble, end quote. Co-author Christopher Glein notes, quote, the underlying geochemistry has an elegant simplicity that makes the presence of dissolved phosphorus inevitable, reaching levels close to or even higher than those in modern Earth seawater. What this means for astrobiology is that we can be more confident than before that the ocean of Enceladus is habitable, end quote. All we need is a mission to Enceladus. Coming up, we take a look at how stars ignite nuclear fission and some new images from Hubble. Stay tuned. This next story left me wondering what young means in astronomy. It's about trying to understand the lives of stars prior to that point where stable nuclear reactions begin in their course. This work is led by Constance Zweitz, who is described as a leader in the young field of astroseismology. When I was a youngling at Michigan State University, we learned about the then new field of astroseismology my senior year, which somehow was more than 25 years ago. In computer science, that would make astroseismology a mature field of research. But in astronomy, where our new general catalog of objects was first published in 1888, astroseismology is pretty much a toddler learning to run, while fields like exoplanetary research are just starting to set up. Anyways, in the toddling field of astroseismology, researchers like Zweitz and his colleagues are combining data on stellar oscillations in infant stars from TESS and Kepler and looking forward to data from JWST. And they are using these oscillations to develop computer models that look at how the interior of these objects change as they form, how they condense and eventually ignite. I love this research because it uses concepts I've used in my research in elder stars in a totally new way. Thomas Steidel, a member of Zweitz's group, explains, quote, research on stars has so far focused mainly on adult stars, such as our sun, even if it sounds counterintuitive at first glance. So far, little attention has been paid to the evolution of the pre-main sequence because the phase is very turbulent and difficult to model. It's only the technological advances of recent years that allow us a closer look at the infancy of stars, and thus at that moment when the star begins to fuse hydrogen into helium, end quote. Astroseismology and the study of pulsating stars both share a basic concept. They look at how a star vibrates like a tuning fork in response to various forces. These vibrations are directly related to the volume and density of material they are passing through. While senior stars, like the variables I looked at, may have simple pulsations that expand and contract entire stars, astroseismologists look at the complex waves that look more like vibrations of an orchestra on the head of a speaker horn. And each of the different waves can reflect different resonances in the star. Stidel goes on to explain, quote, "The classical theory assumes that the time before ignition is simply irrelevant. This is not true. Comparable to a musical instrument, even subtle differences in the composition lead to significant changes in tone. Thus, our modern models better describe the oscillations in real stars." End quote. This is amazing work, and it is a lifetime of work. Team leader Zweitz explains, quote, "I was already convinced about 20 years ago when I first saw the oscillation of a young star in front of me on the screen that I would one day be able to prove the significance of early stellar evolution on the adult star. Thanks to the great work of Thomas Stidel, we have now succeeded. Definitely a eureka moment for our research group and another milestone for a better understanding of the growth steps of stars." End quote. It is amazing to watch both a star and a research field get all grown up. Astronomy is an old field. Thanks to centuries of observations, astronomers have come up with categories for different types of galaxies. Still, like most of the neat little boxes humans make, some things fall out. One such object is NGC 1961 from that new general catalog I had mentioned, which is an intermediate spiral galaxy with an active galactic nuclei. It has spiral arms but lacks the bars of a barred spiral type. Instead, its stars are a big pile at the center, much brighter than the rest of the galaxy. NGC 1961 likely has a supermassive black hole at its center, which affects the evolution of its population of stars and shape by sending large jets of charged particles into and through the galaxy. One of the things Hubble was designed to look for was the observation of individual stars in globular clusters as a way to gain insight into the evolution of these systems. Globular clusters at the center of our galaxy have been hard to study because of the large amount of gas and dust blocking our view. The process of an object dimming to the point of becoming undetectable due to dust or gas is called extinction, and it happens a lot when we look toward the center of our Milky Way. Now, however, combining data from two Hubble instruments and using new processing techniques has allowed scientists to unextinct globular clusters and even determine the age of some of them. One such globular cluster is named Terzon 4. Thanks to the new method, Terzon 4's age has been determined to within about 1 billion years. Considering an order of magnitude is a good measure in astronomy, that's a relatively precise age for this cluster. For those listening on our podcast, we'll have the images in our show notes at dailyspace.org. And now I hand things over to Eric to tell you what's up and bring you some rocket news.
We've had a packed news show today, and we're not quite done yet, but I wanted to briefly mention that Jupiter will be in opposition this coming week, specifically on Monday, September 26th. But it'll be also nearly as high and bright for a few days before and after opposition proper. Opposition is when the Earth is directly between a planet and the Sun, meaning it is fully illuminated as seen from Earth. This opposition marks Jupiter's closest approach in 70 years, so its apparent size will be larger as well. Go outside and look up, but maybe wait until we're done with the show. Still to come is an update on a weather-plagued rocket, a look at an image from the solar orbiter, and a look back at Voyager 1. Stay tuned. In a sign that the seasons have finally changed, SpaceX launched their latest Starlink mission from Slick 40 on the Space Coast on its 5th attempt. The mission was aborted just before launch several times due to weather and barely escaped Earth on September 19th in between storms. We at CosmoQuest hosted live watch parties on Twitch for several of the attempts and were relieved when it finally lifted off. The Eastern Range Weather Officer predicted a 60% chance of violation of weather constraints for the attempt, but Starlink 4-34 made it, and just in time, because Hurricane Fiona is in the Atlantic and could have kept the mission on the ground even longer. Let's watch the launch.
5, 4, 3, 2, 1, ignition, and liftoff of Starlink 4-34. Go Falcon 9. Stage 1 chamber pressure.
Launch weather constraints are very important for rockets to safely deliver their payloads to orbit. Flight through possible lightning conditions is the most significant factor, as a rocket getting struck by lightning can cause damage to its structure and computers, causing control problems. Flight through an area of rapidly changing wind directions, known as wind shear, is also important to avoid, as this can also cause control problems, especially for the very tall and thin Falcon 9 rocket. Active weather systems that lead to violations are often present during the Atlantic hurricane season, which runs from June to November and is most active in September. So it is unsurprising that this launch had so many aborts. Those in the online space community have taken to calling this month Scrubtember, and next month Scrubtober. We'll see how all this weather bodes for the next launch attempt of NASA's Space Launch System, currently set for no earlier than September 27th. As of press time, they have not received the critical waiver from the range about the batteries in the rocket's flight termination system. The range does not budge on public safety, and it is unlikely that NASA will get the waiver. This will delay the launch into October, as the rocket must be rolled back into the vehicle assembly building to replace the batteries. But I digress. In case you are confused by SpaceX's bewildering and ever-changing designations for their internal Starlink missions, this was the 61st launch of Starlink satellites since May 2019. While it's not Friday, here are some statistics. Booster 1067 completed its 6th flight by landing on the drone ship Just Read the Instructions after sending the second stage on its way to orbit. This is the 135th landing of a Falcon 9 first stage, 96th launch from Slick 40, and 180th SpaceX launch overall. SpaceX continues to break their own record for launches in a year. This was the 42nd. The 54 Starlink satellites were deployed into the standard slightly eccentric deployment orbit after one burn of the upper stage. Later on the mission's very first orbit, the Falcon 9 second stage turned around and sent itself into the Pacific Ocean south of Australia. And that, so far, is all the rocket launches we've had this week. While these next stories aren't technically rocket launches or what's up, the things that I normally talk to you about, I'm going to bring you joy with a bit of good news, or at least good images, from Solar Orbiter and Voyager 1. First up, the European Space Agency's Solar Orbiter captured its first image of a, quote, solar magnetic switchback. Solar Orbiter was designed to observe the Sun from a distance, working in combination with NASA's Parker Solar Probe, which will get as close as possible with current technology. Solar Orbiter studies the corona and solar wind, and over years of Venus gravity assists will change its orbit to explore the Sun's poles as well. A magnetic switchback is the, quote, sudden reversal of the solar wind's magnetic field. It presents as an S-shaped band of plasma. Such events may be part of the reason the solar wind spreads far into the solar system and affect interplanetary space. According to paper first author Luca Soroso-Valvo, magnetic switchbacks, quote, have been measured in situ by spacecraft, but are still poorly understood. We hope to be able to observe other similar structures soon to unveil their nature, end quote. The work was published in the journal Astrophysical Journal Letters. Finally, we have one anniversary to mention. Voyager 1 has spent decades in space sending back images of Jupiter and Saturn, including the classic pale blue dot image of the entire solar system, before the spacecraft's cameras were shut down to save power in 1990. But before all of that, they had to be tested. So, 2 weeks after launch, on September 18th, 1977, Voyager 1 looked back from a distance of 11.6 million kilometers and took a picture showing both the Earth and the Moon. The 3-filter composite was shot to properly expose the Earth. The Moon was brightened in post-processing so both would be visible. We'll have the full images for Voyager and Solar Orbiter in the show notes so you can take a closer look. For now, though, this has been the Daily Space. You can find more information on all our stories, including images, at dailyspace.org. As always, we're here thanks to the donations of people like you. If you like our content, please consider joining our Patreon at patreon.com/CosmoQuestX.